Okay, so today we are going to talk about the trends within the periodic table. So you've read that Mendeleev was the first to establish a periodic table, and he did that by atomic mass. And then Moseley came past him after him, and he ordered the periodic table by atomic number, which is what we have today. So you also read about periodic law, and periodic law says that if you order elements by increasing atomic number, then they will have trends or patterns within each group and period. And so that's what we're going to talk about today, are those trends. So the first trend we're going to talk about is atomic radius. And so atomic radius is just the size of the atom. And it's measured by taking, if I have two atoms bonded together, there's the nucleus. Sorry, let me do it. Yep. No, stop doing all that. Two dots. There's my nucleus. What it does is it's the distance between two radii. So that's really, that's why it's called atomic radius. Because as we've learned in the last unit, the size of the electron cloud is kind of, it's big and it's large, but we really don't know where it begins and where it ends. So if we take the distance between two bonded atoms of the same type, the distance between their nucleus, we've got the relative size of the atom. And so the trend, we'll have two trends. We'll always have a period trend and a group trend. So we'll start with the group trend. The group trend is that atomic radius increases as you move down a group. And the period trend is that atomic radius increases as you move left across a group. So if I sketch out a periodic table here, there we go. The trend increases as you move down and to the left. So francium in that corner here is the largest element on the periodic table. Okay, let's take a look at some examples. So I want you to take a look at a periodic table, either the one on the wall or if you grabbed one. Look at sodium and aluminum and decide which one would be bigger given the trend. If you picked sodium, you were right. Remember, the period trend is that it increases as we move left across the periodic table, and sodium is further left than aluminum. Let's try one more. Sulfur and selenium. Sulfur and selenium. Which one is larger? If you picked selenium, you are correct. The group trend is that atomic radius increases as you move down a group, and selenium is further down than sulfur, so it would be the larger atom. That is atomic radius. We're going to move on to the next trend, which is ionization energy. But before we can talk about ionization energy, we've got some vocabulary we need to address. So ions are elements, or atoms really. We're going to say atoms. Atoms that have lost or gained an electron. Okay, so if you'll remember to biology, when you talked about acids, you talked about H plus and maybe even OH minus. So these are ions. This is a hydrogen ion. To be positive, it has lost an electron. So now we have more protons than electrons. And this is called a cation. So a cation has lost one or more electrons. It has lost one or more electrons. A way to remember that is a plusy cat. So the plusy cat, you also in cat ion, you have the T, which is your plus sign, the T here. So those are two ways to remember that. So plusy cat, which I think is kind of funny. And then the T in cat ion makes a plus sign. So that hydroxide is not a great one because it's a polyatomic. But if I were to give you an example like Cl minus, that means chlorine has gained an extra electron, so that's why it's got a negative charge. If I gave you something like nitrogen 3 minus, that means it gained 3, or it lost, gained 3 electrons. Okay, so that's, the plus is lost and the minus is gained because we're gaining negative. So for an anion, you gain 1 or more electrons. Okay, so anion sounds like onion, and onions make you cry. Or the A has a minus sign right in there. So it's A, there's your minus sign. However you want to remember that. Okay, so ionization energy, so how do these things relate? So now you know what an ion is. So ionization energy is the energy required to remove an electron from an atom. And I will say ionization energy atom. Ionization energy increases as you remove the second and the third electron, but we are only going to talk about when you move that very first electron. So it's the energy required to remove an electron from an atom. So this is making cations. All right, so the trend, the group trend is going to increase. So ionization energy, it becomes harder to move an electron from an atom as you move up a group. Remember, groups are the columns and periods are the rows. The period trend is that it increases as you move right across a period. My handwriting just keep getting worse. Sorry guys. I'm going to scroll down some. That might help. I've got a little more room. So I'm going to draw out our periodic table again. There's my sketch. So ionization energy increases as I move up and to the right. So helium here, that's helium. Helium is the hardest element atom to take electrons away from. He has the highest ionization energy. He has the highest ionization energy. Okay, so let's take a look at two examples again. Let's start with manganese or zinc. Manganese or zinc. Now this time I want you to tell me which one has the lower ionization energy. Manganese or zinc. Which one has the lower ionization energy? If you said manganese, you are correct. Manganese is further left on the period, so it is going to have a higher or a lower ionization energy. All right, we're going to do the same thing. So lower ionization energy between magnesium and barium. Which one is going to have the lower ionization energy? If you said barium, you are correct. Barium has the lower ionization energy because it's further down a period. So magnesium is higher and zinc is higher. That was our third trend, or our second trend. We're going to move to our third and final trend, which is electronegativity. So electronegativity is the attraction for another atom's electrons. So this is between atoms of different types. So we want to see, it's going to deal with bonding, which is what we're going to move to after Thanksgiving. We're going to move to after Thanksgiving bonding. So that all of this plays into bonding, but especially electronegativity. Because if I have a high attraction for another atom's electrons, I'm going to take those and we are going to be bonded together. So we'll talk about that then. But it's the attraction for another atom's electrons. So an element with a high electronegativity is more likely to take electrons, and an atom with a low electronegativity is more likely to lose electrons. So that's how that works. So the trend, again, I don't have enough room. I may have to skip, actually. Let me just put a space in there. Okay. Bring this up. Sorry, guys. Okay. So the group trend increases as you move up a group. So if you'll look, it's just like ionization energy. And the period trend is it increases as you move right across a period. So ionization energy and electronegativity have the same trend, and that makes sense because if I have a high ionization energy, so it takes a lot of energy to take my electrons, then I'm going to not lose them. I'm going to take somebody else's electrons before mine are taken. Just like in ionization energy, if I have a low ionization energy, meaning it's not really hard to take my electrons, then I'm going to have a low electronegativity because I'm not going to be attracted to another atom's electrons. I'm going to lose electrons. All right, so we can draw this again, and I want to pay special attention. Remember, these guys are our noble gases. So we're going to mark those out, and this trend goes right and up, and it leaves out the noble gases. So that brings us here. Noble gases, their electronegativity value is 0. Noble gases are stable on their own by themselves, so they don't bond with other atoms typically because they're already stable, so their electronegativity is 0. They are noble and they stick their nose up in the air. So they don't play well with others, so they don't have an attraction for another atom's electrons because they just want to be by themselves. So that's 0, so that's why we mark that out. So if we look at some examples, let's take a look at nickel or platinum. Nickel or platinum. Which one would have a higher electronegativity between nickel and platinum? If you said nickel, you are correct. It is higher in the group, so it's going to have a higher electronegativity. Then if we take a look at, let's do cesium or lead. Cesium or lead. Which one of those would have a higher electronegativity? If you said lead, you are correct. It is further right on the periodic table. So lead is going to have a higher electronegativity. All right, so I told you that all of this leads to bonding, which is reactivity. Do things react together to form bonds? So metals typically lose electrons, and our alkali metals, so those metals in the first group, are the most reactive. And then nonmetals. Nonmetals tend to gain electrons. Nonmetals gain electrons, and the halogens are the most reactive. So if you'll remember back to chapter 1, remember I've told you chemistry, it doesn't go away, so we're coming back to chapter 1. Your alkali metals are your first column, your halogens are this next to the last column. Okay, your nonmetals are on the right hand side of the periodic table, and your metals are really the rest of it. Okay, so we've got the metalloids, those 7 that make that staircase. The nonmetals are to the right of that, and then all the metals are to the left. So metals increase in reactivity as you move left on the periodic table, and nonmetals are going to increase reactivity as you move right towards those halogens, but the halogens are the most reactive.